my x-intercept occurs at the 0 of my numerator. So I set that equal to 0. I'm going to solve for x. When I do that, I'm going to get x squared is 3/2. So x is going to be plus or minus the square root of 3 over 2. Now, in every other section that we've ever done, at this point we would rationalize our denominator. But if you stop and think for a second, does it matter if I rationalize my denominator? Because I'm just looking to figure out where to put this on a graph. It does not matter. Okay? You do not have to rationalize your denominator. What you need to do is come up with some decimal equivalent for it, so that way when you're plotting it on your graph today, you know approximately where it's at. And if I'm not mistaken, I think it's about 1.2.
Yeah.
Is that so? If it's at about 1.2, it's about here and about here. You're still telling me that the intercepts for the x-intercepts are occurring at plus or minus the square root of 3 over 2. You can say that now. You do not have to rationalize denominators in this with this stuff. Okay? Does that make sense?
Yeah.
Don't do it. Just leave it like that. Okay? Next, we go to our vertical asymptotes. Your vertical asymptotes occur at the 0 of the denominator. In this problem, it was x equals -2. So I know that on my graph, I put a vertical asymptote at x equals -2. Now I start playing the game of the horizontal asymptote. And you had 3 cases. M is less than n. Remember, m and n deal with your degrees of the numerator versus denominator. M is up top, n is down below. We had the 3 possible cases, and what happens here is that you have at most, and this is kind of, oops, hit the wrong one here. If m is less than n, y equals 0. If m is greater than, we have none. And then here is where you're worrying with the coefficients. The coefficients are going to be your ax squared, blah, 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 whatever this m degree is over bx to the n. These are those coefficients. If you recall on a couple of these graphs, there were times where you had a graph crossing what should have been a horizontal asymptote. The reason that does occur is because these could happen. You don't know if they actually do occur until you look at it on the table function with your calculator, okay? So you will see sometime within the boundaries, especially those that have dual vertical asymptotes, you'll see that middle curve go through what you think would be the horizontal asymptote. It does happen, okay? I think we talked a little bit about that yesterday. I just want to re-emphasize that. So in this problem here, I lost where we were at. Oh, there we go. Our horizontal asymptote, excuse me, we have no horizontal asymptote, so I just write down none. Now, all we have to do is to get ordered pairs. When we're graphing these things tonight and then tomorrow with the quiz, I will have on here give me ordered pairs. Because once you get this information, it's a matter of pressing buttons and getting the table out. Yes, ma'am?
When you did it yesterday, did you find the x-intercept and then take the next 2 of them?
I did it with the asymptote. Not the x-intercept, I did it with the asymptote. Because if I have my asymptote at +2, or excuse me, -2, I'd look at what's happening at -1 and 0, and I'd look at what's happening at -3 and -4.
Okay.
I'm looking at in those boundaries. Now, when you graph this one in your calculator, it probably looked like this, and then you didn't see anything over here because your window didn't show it. But if you look at your table, you'll see, I think at -3, it's -15. So it is occurring way down here.
Were we supposed to look
No, you weren't yesterday. I'm just showing you guys your next steps to do these problems would be to just put that in your calculator and look at the table function. Okay? Does that make sense? So for those of you guys that only saw this curve in your graph, the reason why you only saw that is because the other part is further down below in your window. Yeah?
Could you explain how you find 27?
I'm getting there.
Okay, you're gonna do.
Yeah, I'm going to go through all 6 of these real fast, and then give you guys time to start working on the last 6 of these to look at. All right. Yeah.
Without doing the thing in the you know to graph it by using those points.
What I know to graph it is that at this point, I don't know what these curves look like after just this information. I could plot that all day long. Once I get that information written down, that's when I put it into my calculator to look at the table. And then that'll let me find all my ordered pairs. Okay? You don't have to generate this by hand. You will be able to use your calculator. But you have to be able to find this information. The information in here. Okay? That's what you have to be able to show.
Okay, but when you assign that information, should we know how to graph it?
No, you probably won't. Without looking at a table or actually looking at the visual of the graph, you're not going to know what direction it's going. I don't expect you to know, oh, this is going to go through that. Yeah, I don't even know how to do that off the top of my head. 27. Same thing. We start, again, our x-intercept. Do I have anything to set equal to in the numerator to find an x-intercept? No. So do I have an x-intercept? Nope. My vertical asymptotes. I don't have anything that's going to give me a real solution in the denominator, so I have none. My horizontal asymptote.
0.
You're saying it's y equals 0, and why is it that?
Because n is greater than m.
Good. Since the denominator has a higher degree than the numerator, y equals 0 would be your horizontal asymptote.
So that's all we have to do?
From yesterday, that's all you need to be able to do. Today, the next step would be to go take a piece of graph paper out, oops, put this in my calculator, and I'll show you how that works again. We have y equals alpha, y equals, enter, negative 24 over x squared plus 8, and I just hit my graph. I know it's going to look like that. All I have to do then is go to my table. Then with my table, I'll be able to list my ordered pairs. And just write down your ordered pairs, and then you'll get your points to plot. Came up here again there. And your table will allow you to. Your table will give you ordered pairs. Okay? The table will give you all of your ordered pairs. You do not have to come up with them on your own. Okay? Sometimes they're going to be nice and clean. Sometimes they're going to be kind of nasty. If it's a nasty fraction, just figure out what the decimal value is if you have to figure out where you're going to place it within the graph. Okay? Yes, sir? You didn't have to, but if you did, then you're ahead of the game right now. Then you know what you're looking for in your calculator, which is fine. All right? What I was hoping that you guys, all you had to do really last night was to just start working with solving for x-intercepts, vertical asymptotes, horizontal asymptotes. And you took it a step further? Great. Not a big deal. Okay? What's wrong? I didn't even realize that.
It's the math teacher by Joker.
Never even noticed that. Again, in this one here, our x-intercepts are what? Letter?
Negative 2 and positive 2.
Yep, plus or minus 2. Vertical asymptote? None, and the reason is? No reals again. Very good, no reals. And what about horizontal asymptote? Good. Again, when I go to here, oops. X-intercepts plus or minus 2. Horizontal asymptote at 1. Oops. table function. You go to your table. Let's see. X squared minus 4. X squared plus 3. And you'll get some decent, I mean, they're not pretty, but you have some decimal equivalencies that you can mess around with and kind of fudge where it's going to go. On the quiz itself, you will have it written out basically what you need to show, what has to be there. So just like I'm listing right now, I'm saying, all right, what is your x-intercept? What is your vertical asymptote? What is your horizontal asymptote? It's going to have blanks for all of that, so you don't forget what parts to look for. And it'll also have, if it's a graphing problem, it'll have sets of ordered pairs for you to fill in. And it sometimes, remember how we had a problem yesterday where it's split into 6 possible quadrants, or whatever they're called, spaces? Then we would have more ordered pairs there for you to fill in. Okay? Not so bad? Yes, sir.
You have 4 ordered pairs on the quiz. Do you know, like, is it any, is it, which,
Usually when you set these up, you're looking for 2 on either side of a vertical asymptote. In this problem here, there's no vertical asymptote, is there? If I'm asking for 4 sets of ordered pairs, what would you give me? Looking at this graph, what would you give me?
the x-intercepts?
Okay, x-intercept,
Like
a couple positive, a couple negative maybe? That's really all you need.
y. So it can be any coordinates on
Yeah, as we go through that one, oh, B, judge, must pause. All right. Let's look at 30. Oops.
And I couldn't get any, nothing at none.
Well, when you have to set up a problem like this, you obviously have to do factoring.
Yeah.
So when you factor your numerator to find your x-intercepts are going to be located at the zeros of the numerator. 2x squared plus 3x plus 1 equals 0. What's that? No, you're right. It's 1 and 2. 2 times what, or what times what is 2 you add together to get 3? 2 and 1.
But then don't you have to take the opposite of it?
But he's got a leading term coefficient that's not equal to 1, so you have to do the grouping. So you wind up with 2x squared plus 2x plus 1x plus 1.
You gotta find
Do your GCFs. So your intercepts are at -1 and -1.
Did you resume on this one?
Okay. So that's how you get your zeros on that. Now you know that your intercepts are located at -1/2 and -1. Okay. Go to your vertical asymptotes. Again, you have to factor your denominator. Factoring in the denominator, this one's going to be a lot easier.
Oh, yeah. 1.
Oh.
Yeah, -1, -4. So your zeros are at 1 and 4. So your asymptotes are at x equals 1, x equals 4. We throw those in with the dotted line. And now we look at our horizontal asymptote. Our horizontal asymptotes can be located where? 2. Very good. It's going to be located at y equals 2. Again, the reason that is because our degrees are identical, so then we worry about our coefficients. So it's going to be at y equals 2. So we throw that one in. Oops. This is one of those cases where you see how it's broken into 6 possible areas to look at. Everybody see that? So if I'm looking to list out ordered pairs in a problem like this, what I need to do is I'm going to take 2 ordered pairs in this area, 2 ordered pairs in between, and then 2 ordered pairs over here. That'll give me a visual representation of what the curves are doing. Again, your calculator will do that for you. I'm not taking it away from you. You still have to be able to give me all of this information, which the calculator does not provide. All right? So when you plot those things through in your graphing calculator, you're going to find out that I believe it curves kind of like this, and then it goes like that, and curves back that way, I think. Yeah.
Is this 30 or 29?
This is 30.
For 30, you got like a little bump at the bottom.
Yeah, the bottom just a little.
In the middle.
Oh, it's just, I'm thinking of a different problem then. Oh, I'm thinking of one from,
It's really weird.
okay. I'm thinking of a problem that you'll have later on today. So within those values, again, all you're going to have to be able to do is list out ordered pairs. Does that make sense about having to list them in each of those 3 general areas by picking pairs there? Again, graphing of it is the easiest part of all of this because it's just pressing buttons. The legwork comes in when you have to list out the information. And then the last one. I'm getting nervous they're not showing up.
Maybe they judged earlier.
But it wasn't on and nothing was running.
You still have 20 minutes,
I'm not a very patient person.
You said that already, Jack.
X-intercepts. Where will your x-intercepts be located in this one? 0. Very good. Everybody agree?
I don't know.
Set the numerator to 0. What's x equal to then? If I set the numerator equal to 0, 2x squared equals 0, what makes it 0? 0. Set the denominator equal to 0, what do you get for your vertical asymptotes? Good. Do we have horizontal asymptotes here?
No, John.
I don't, because the numerator has a higher degree. Okay? Again, this information, you should be able to just go ahead and write through. The rest of the problem is using the calculator. When you get to the rest of the problem again, why does it always disappear?
You would.
Silly computers. X-intercept at 0, vertical asymptote at -2. Use the table function in your calculator, plot some points. Since it's just at the singular vertical asymptote, 2 on the left, 2 on the right. There you go.
So you do like the one right next to the vertical.
Yeah, but remember, your table's going to help you out here. If those values wind up being god-awful number stuff, if there's an easier number to work with that's going to give you an integer value that's going to be easier to find, use that one. It's not a big deal. Okay? It really isn't. All right? Is that making sense? Did it make sense for you?
Yeah.
Good.
Frankincense. What is that? Heard of it? Has anybody else heard of frankincense? Is that like a?
Isn't that one of the?
I think it's an herb.
Isn't what the thing? That's what the 3 wise men had.
Yeah.
The frankincense, myrrh, and gold, right?
Incense,
Yeah.
or something like that.
No,
Was it?
It's
kind of incense.
Is it Frank? You're right. It's like one of the 3 wise men had.
It wasn't incense.
Not Franken beans.
It's like a spicy thing.
Yeah, definitely not frankincense. I know it's not frankincense.
What I want you guys to do are the next 6 of these. I'll collect these 6 tomorrow. And then when you're doing these, there's going to be a little bit of a trick here because you're going to have some of these cube root stuff. And then we'll walk you through how you set this up. You still solve zeros the exact same way. But again, what's your x-intercept? What's your vertical asymptote? Where's your horizontal asymptote? And then sets of ordered pairs. When you plot it through. Yes, sir?
The only question I had was why can't you just like cancel out the x cubes?
You can't because of
The addition.
the addition and subtraction.
Okay.
So if I'm looking at that first one, yes, sir?
Are you collecting these tomorrow?
No, I'm gonna collect these 6.
Not these
The
ones.
ones
No,
that we had yesterday.
these are the first, because I wanted you guys to get this information, okay?
The friends we did.
Yes.
Yeah, the stuff that was due yesterday, give me that stuff, I'll get that from you. So if I'm looking at this first one, where it's 3x cubed plus 1 equals 0, and I need to find the 0 of that numerator, yeah, they both are cubed. So if I'm going to find the 0 of that numerator, I set it equal to 0, and I'm going to solve for x. Again, this should not be horribly bad. We're going to get x cubed equal to -1/3. Is everybody okay with that? Subtract 1, divide by 3. How do you undo cubing? You cube root it. So x is going to equal the cube root of -1/3. Now, can I take the cube root of -1/3? I can. And why can I? It's negative and it has an odd power, or an odd nth root. So I can find that. Now, do I need to,
I have two of these.
that's fine. Do I need to rationalize this thing? Can I take your homework?
Yeah, you took the.
Notes?
No, this is
Oh, sorry. Do I need to rationalize this?
No.
No, what do I need to find? Just, yeah, a decimal-ish. What is this, -1.2, I think? Or negative, no, it's about -0.7. I'm thinking of a different problem.
-0.697.
Yeah, it's about -0.7. Because we're just kind of getting a rough estimate here. So I know that I have an x-intercept. You're telling me that it's at the square root of -1/3, or excuse me, cube root of -1/3. But when I go to put that on a piece of graph paper, it's okay that I kind of guesstimate it to be about here and here. That's okay. Does that make sense? We're doing a decimal equivalent of what it is. Yeah.
Wait, why do you have positive points on everything?
I don't know. I was thinking square root off the top of my head. Thank you.
I'm just wondering.
That's okay. When I go to get my vertical asymptotes, I set the denominator equal to 0. Again, I'm going to solve for x here. Add 32, divide by 4.
8.
So I have x cubed is 8. What's the cube root of 8 then? 2. Good. All right. So I have then a vertical asymptote at +2. Horizontal asymptotes. Do I have a horizontal asymptote here? I know it's not blowing up very well. It's 3x cubed over 4x cubed. The degrees are the same, so what's my asymptote?
Oh, it's
3/4. And again, it just so happens to be kind of weird looking like that. Could you go to your table function in your graphing calculator at this point, list out some ordered pairs? Yes? Good.
How many multiples do you want?
For this one, you only really need 4, 2 on each side. The times that you're looking to have multiple ordered pairs are going to be the ones where you have that extra upright. When you have it split into something like that, you want to look at something going on in between those two as well, as what's helping out the tails. Does that make sense about when you need that extra set? When we take the quiz tomorrow, it's going to be basically this stuff and what we looked at on Monday, the A, H, and K. Remember, when you had the A, H, and K, it was kind of the same idea. It was a little bit simpler than this. Your vertical asymptote was still at the 0 of the denominator, and your horizontal asymptote was your K value. When you had the other one where it was AX plus B over CX plus D, your asymptote for your vertical was still 0 of the denominator. Your horizontal was your A over B. Okay? So, very straightforward. Not taking the calculator out of your hand. You just have to be able to list out the important parts. Calculator doesn't allow you to be able to do that unless you know what that means as you're going in. Okay? Questions? Yes.
Is it a full like class quiz?
I think it's like 5 questions. It probably won't take long.
Oh, we'll have a
Is that-
little
is
free
that
day
what
after.
you know?
I don't know. What's that? That's all we're doing. I don't know. Maybe we might start. I don't know.
And then Friday's free day. Friday's a party day because we
We're,
get
if we get pizza, we'll play it by ear.